Welcome to our YouTube channel, Paper Vault, where we are solving past paper questions of IGCSE Chemistry. We are doing mole and Avogadro's numbers questions, past paper questions of P2 at the moment. And you've seen questions 1 to 21 in our part 1 video, and inshallah now today we are going to be starting our part B, which will have the rest of the questions related to this topic. So let's begin. But before we start, kindly like and subscribe the channel, and if you found anything helpful in the channel, kindly remember me in your prayers. So let's start. Question number 22. A sample of dilute nitric acid is added to lumps of limestone in a conical flask. Conical flask is placed on a balance and the loss in mass is measured. A second sample of nitric acid of different concentration is separately tested. All other conditions are kept the same. The loss in mass in 1 minute at each concentration of nitric acid is shown. Like when the concentration was 0.5 mole per decimeter cube, the loss in mass in 1 minute was 0.15. And when the concentration was 1.0, the loss in the mass was 0.25. So which row describes and explains the result obtained using 1 mole per decimeter cube of nitric acid compared with 0.5 moles per decimeter cube of nitric acid? Okay, the reaction would be, we say this is not important, but still I am writing it. HNO3 will give you CaNO3 plus CO2 plus H2O and H2. This is going to be balanced. Okay. Now everything counts on the concentration. When the concentration was 0.5, so the loss in the mass was 0.15. And when the concentration was 1 mole per decimeter cube, so the loss in mass was 0.25, which is greater than this. So why is this happening? When the concentration is greater now, so the rate of the reaction basically increases. Obviously, more CaCO3 is reacting vigorously with the nitric acid. Okay? So that is why the reaction is happening at a higher pace. Okay? Quicker pace. And why is this happening? Because the collision between the particles increase. Okay? So when we look at our options, so decrease in the reaction rate, decrease in the reaction rate is not the answer to more loss in mass when more concentrated solution is being used. दोनों का होगा increase in reaction. So explanation is increase in particle collision rate, increase in particle collision rate and collision energy. No, it's just increase in particle collision rate. So C is going to be our correct one option. Question number 23. Calcium carbonate reacts with dilute hydrochloric acid. The equation for the reaction is shown. 1 grams of calcium carbonate is added to 50 centimeter cubes of 0.0500 mole per decimeter cube of hydrochloric acid. Which volume of carbon dioxide is made in this reaction? Acha, now we've been given the mass of calcium carbonate and we've been given the concentration and volume of hydrochloric acid. So we are going to find the moles of calcium carbonate and then we are going to find the moles of hydrochloric acid, since they've not mentioned the fact that which one of these reactants is limited and which one is in excess. So we have to find first their moles with their mass and concentration, and then we are going to compare them and see which one of these reactants is the limiting reactant and which one moles should we use to find the volume of carbon dioxide. So finding the moles of CaCO3, mass is 1 and CaCO3 ka MR is 100, so 0.01 moles. So to find the moles of HCl, we are going to use our formula concentration is equal to moles over volume. But the volume over here you can see is in centimeter cubes, so we need to convert it into decimeter cubes. So we are going to divide it with 1000, so this is going to be 0.050. ठीक है. So concentration is 0.0500 is equal to moles and the volume is 0.050 decimeter cubes. Oh, एक second. Decimeter cubes. ठीक है. So after we multiply this, so we are going to get 0.0025. So according to this concentration and volume, the HCl that is present in the reaction is 0.0025. Now we need to see that how much was required for this reaction to happen with calcium carbonate. Okay, so how are we going to do that? We are going to find the ratio. Okay, CaCO3 is 1, HCl is 2 moles. CaCO3 ke moles are 0.01, and to find the moles of HCl we have X. So we have X is equal to 2 into 0.01. So this is going to give us 0.2 moles. Okay, now this much moles of HCl were required in this reaction to completely take place. Okay, but the concentration and the volume which was present in reality in this reaction was just 0.0025. So now you can see that HCl is the limiting reactant. Okay, it was required to be 0.2 moles, but it's there only in 0.0025 moles की quantity में. ठीक है, so we are going to use the moles of HCl because this is a limiting reactant. ठीक है, to find the volume of carbon dioxide. Okay, carbon dioxide and HCl. अभी हमें we need moles of carbon dioxide. So how are we going to do it? HCl and CO2. HCl is 2 moles. This is 1 mole. So HCl के moles are 0.0025 and X. So 2X is equal to 0.0025, and this is going to give us 1.25 into 10 raised to the power minus 3 mole of CO2. ठीक है. Once we have the moles of CO2, there is no issue in finding its volume. We can always use our formula moles is equal to volume over molar volume, and as in the answer it's given in centimeter cubes, so we can use 2400 centimeter 24,000 centimeter cubes, or we can always use what do you say 24 डेसीमीटर क्यूब्स. ठीक है, तो हम अभी जो है ना यहाँ पे डेसीमीटर क्यूब्स में यूज करते हैं, देन वी आर गोइंग टू कन्वर्ट इट इन द एंड बिकॉज दिस आंसर इज इन दैट. तो 10 raised to the power minus 3 volume we need to find, and this is 24. So 24 into 1.25 into 10 raised to the power minus 3 is going to give us a volume of 0.03 in decimeter cubes. ठीक है, and we need to convert it into centimeter cubes. So we are going to multiply it with 1000, and this is going to give us 30 centimeter cubes. The 30 centimeter cubes of carbon dioxide was made when calcium carbonate and HCl were reacted together. So A is our correct answer. Chalo, let's go on. If I need to, I'll clear the space. Question number 24. Magnesium carbonate decomposes on heating to form magnesium oxide and carbon dioxide as shown. How much magnesium carbonate is needed to make 5 grams of magnesium oxide? Okay. So this is a little bit of a reversal type of a question. We haven't been given the moles grams of the reactant, but we have been given the mass of the product. So we can easily find the mass of the reactant. Okay, no issues in that. Okay. So first thing is first, we are going to find the moles of MgO. ठीक है, its mass is 5 and its Mr is going to be oxygen is 16 and magnesium, so it's going to make it 40. ठीक है, so moles of MgO are 0.125. And if we look at the reactants and products, so magnesium carbonate and magnesium oxide are in a ratio of 1:1. So the moles of magnesium carbonate and magnesium oxide will be the same. So once we've found that, so we can easily find the mass of magnesium carbonate. Again, using the same formula, moles is equal to mass over Mr. So moles are 0.125 and mass we have to find, and the Mr for MgCO3 is 84. ठीक है, तो 84 into 0.125 is going to give us a mass of 10.5 grams. ठीक है, so 10.5 grams of MgCO3 has to be heated to give 5 grams of magnesium oxide. ठीक है, so D is going to be our correct option. Okay. Moving forward to question number 25. So I'll just clear the space first. Okay, 25 centimeter cubes of 0.100 mole per decimeter cubes aqueous sodium hydroxide is neutralized by 24.6 centimeter cubes of dilute sulfuric acid. What is the concentration of dilute sulfuric acid? Okay. Dilute sulfuric acid की concentration we need to find, and we just have its volume, we don't have its concentration. So what we are going to do is, we are going to find the moles of sodium hydroxide, and then with those moles we will find the moles of dilute sulfuric acid and then its concentration. So first thing is first, we should write our reaction. Okay, so this is NaOH being neutralized with dilute sulfuric acid, which is H2SO4. So this gives us Na2SO4 plus H2O. ठीक है, and here are 2 sodiums and 2 hydrogens, so 2 is going to come over here, and okay, now this is a balanced equation for this reaction. So let's find the moles of NaOH with its concentration and volume. So moles, we are going to write concentration is equal to moles by volume. So concentration is 0.100 and moles we are finding, and the volume is 25 centimeter cubes. So this has to be converted into decimeter cubes by dividing it with 1000. So this is going to give us 0.025 decimeter cubes. Okay, so when we multiply this and this, we are going to get 2.5 into 10 raised to the power minus 3 moles as an answer. So these are the moles of NaOH. So now we can just simply find the moles of H2SO4. I've just told you that this is your best friend. Okay, so here we know that from a balanced equation there were, if we write NaOH and H2SO4, so 2 moles of NaOH were there and 1 for H2SO4 was there. So 2.5 into 10 raised to the power minus 3 moles of NaOH are there. So moles of H2SO4 have to be found. So this is 2x is equal to 2.5 into 10 raised to the power minus 3. So when we divide this with 2, we find the number of moles of H2SO4. 1.25 into 10 raised to the power minus 3 moles. Now once we have the moles of H2SO4, there is no issue in finding its concentration. Okay, we will use our formula, concentration is equal to moles by volume. We have the moles as 1.25 into 10 raised to the power minus 3, and we have the volume as 24.6 centimeter cubes, and we have to change it into decimeters cube by dividing it by 1000. So this is going to give us 0.0246 decimeter cubes, and after we divide this, the concentration of HCl would be 0.0508 mole per decimeter cubes, and the answer is also in mole per decimeter cubes. So A is our correct option. Okay. Moving forward to question number 26. 90 grams of glucose is dissolved in water. The glucose solution is fermented. After fermentation finishes, 6.8 grams of ethanol is obtained from the solution. What is the percentage yield of ethanol? Okay. In this question, we have been given the actual yield of ethanol, and as we know that the formula for percentage yield is actual by theoretical yield into 100. Okay, so we've been given the actual yield, but we have to find the theoretical yield. Okay, how are we going to do that? We are first going to find the number of moles for glucose, and with the help of that we are going to find the moles of ethanol and then see what's the actual. Okay, so first thing is first, we are going to find moles of C6H12O6, which is glucose. So the mass of glucose is 90 and the MR for glucose is let's see, 180. Okay, so this gives us the number of moles to be 0.5 moles. Okay, now we have the moles of glucose, so we are going to find the moles of ethanol according to the reaction. Okay, so C6H12O6 and here we have C2H5OH. So 1 mole of glucose and 2 of ethanol and 0.5 moles and X. So X is equal to 0.5 into 2 is going to give us the moles of ethanol, which are going to be 1. ठीक हो गया? Once we've done that and we've established how many moles of ethanol are there, we are just going to find its mass. So how do we do that? Moles is equal to mass per mr. So moles हमारे पास 1 है, mass we have to find, and mr for ethanol is given over here as well, which is 46. 46 grams of ethanol are produced in ideal circumstances, obviously. So this is our theoretical yield, and this is our actual yield. So now if we put these two in the formula, so the actual yield is 6.8 grams and then the theoretical yield is 46 grams. The theoretical yield is 46 and multiply by 100 is 6.8 into 100 divided by 14.7%. So C is going to be our correct option. ठीक हो क्या? Question number 27. A tablet contains 0.080 grams of ascorbic acid. What is the concentration of the ascorbic acid when one tablet is dissolved in 200 centimeter cubes of water? So concentration हमें find करनी है. So concentration का formula is moles over volume. So we have our volume, but we don't have our moles. So we need to find the moles. How are we going to do that? Moles of ascorbic acid would be mass by mr. So mass is 0.080 and mr has been given as 176. So this is going to give us moles of ascorbic acid to be 4.0. ठीक है, once we have the moles we can put them in this formula and find concentration 4.54, and the volume is 200 centimeters cubes, and it has to be converted into decimeter cube, so this is going to be 0.2 decimeter cubes. ठीक हो गया? So when we calculate this, so we get an answer of 2.27 into 10 raised to the power minus 3. So I think this is going to be the answer. We can round it off to 2.3 and rest of the answer is okay with us. ठीक है? D is the correct answer. Okay. Question number 28. What is the concentration of a solution that contains 25 grams of NaOH in 500 centimeter cubes of water? So again we have a question related to concentration. I've just told you that formula for concentration is moles per volume. So we have the volume, but we don't have the moles. So first thing that we need to do is we need to find the moles of NaOH. We use the formula mass over MR. So the mass is 25 and MR for NaOH is 40. So 25 divided by 40 gives you 0.0625 moles. So now if you put them in this formula, this is going to be 0.0625 divided by the volume, which is 500 centimeters cubes. So we need it in decimeter cubes, so 0.5 decimeter cubes. So after we divide this, so we are going to get concentration of 1.25 mole per decimeter cube. So C is going to be our correct answer. Okay. Question number 29. Calcium carbonate reacts with dilute hydrochloric acid according to the equation shown. 10 grams of calcium carbonate is reacted with 100 centimeter cubes of 1 mole per decimeter cubes of hydrochloric acid. The following statements are made. Which statement about the reaction is correct? Achaji, we need to know that how many decimeter cubes of carbon dioxide was formed. 5.6 grams of calcium carbonate is formed. Okay, 4.8 of carbon dioxide is formed. No calcium carbonate is left when reaction is completed. Acha. This is a long question. So again, I am suggesting you the fact that if you are doing this in the paper, so leave it for the last. Okay? Because there are so many steps involved. First, what we need to do is we need to find, this question has everything related to moles that we've learned, and we have to do that. First of all, we are going to find the moles of CaCO3. Okay? And how are we going to do that? We have the mass and we have its MR as 100. So this is going to give us 0.10 moles. Okay? With the help of that, अच्छा वो next step में करेंगे, we are going to find the moles of HCl as well, because we've been given the concentration and what do you say, volume. So that is going to be concentration is equal to moles by volume. So concentration is 1 mole per decimeter cubes, ye moles mein, and then again we have to convert it into decimeter cubes because the concentration is in mole per decimeter cube. This is going to be 0.1 decimeter cubes. So moles are going to be 0.1. ठीक हो गया? Now we have mole of HCl, we have moles of calcium carbonate, and if you see that one of the statement that has been made is that no calcium carbonate is left when the reaction is completed. Yani this states that calcium carbonate is a limiting reactant. So we have to see that which one of these is limiting and which one of these is in excess. Okay? How do we do that? We have moles of CaCO3, we have moles of HCl, that of HCl. CaCO3 is 1 mole, this is 2, and moles of CaCO3 are 0.10, and we have to find the moles of HCl that were required for this reaction to completely get completed. So 0.10 into 2 is equal to x. So this is going to give us moles of 0.2 moles. ठीक है? So we needed 0.2 moles, but according to the statement of the question, we just have 0.1 moles, ठीक है, of HCl in this reaction. So this means that HCl is the limiting reactant and CaCO3 is in excess. We don't have enough HCl to completely eradicate calcium carbonate or use in the reaction. So first thing that we found is that the statement 4 is not correct, because this would have only happened if 0.2 moles of HCl were present. This moles of carbon dioxide required 0.2 moles to completely get used in the reaction. Okay, we don't have them. So once we found this out, we know that we have to use 0.1 moles of HCl to find how many decimeter cubes of carbon dioxide was formed. Okay, like we need to find the volume of CO2. So how are we going to do that? We are going to find the moles of CO2 first. So HCl and CO2. 2 of HCl, 1 of CO2, 0.1 of ye and x. 2x is equal to 0.1. So 0.1 divided by 2 is going to give us 0.05 moles of carbon dioxide आ दिया. ठीक है? Once we've reached 0.045 moles of carbon dioxide, now we can find the volume. The volume is going to be found by the formula moles is equal to volume by molar volume. So moles are 0.05, volume we had to find, and this is in decimeter cube, so we are going to use 24. So 24 into 0.05 is going to give us 1.2 decimeter cubes of CO2. So this is correct that this is formed. Now they are asking us that were 55.6 grams of calcium chloride was formed. So how do we find calcium chloride? Okay. We have moles of HCl and we can find the moles of CaCl2. So ये HCl2 है, CaCl1 है. HCl is 0.1 and this is X. So this is going to give us again 0.05 moles. ठीक है, सो अब हम इसका देख सकते हैं कि वह 5.6 grams obtained. मोल्स इज इक्वल टू मास ओवर mr. मोल्स हैं जी 0.05, मास हम ढूंढ रहे हैं, और CaCl2 का जो mr है वो होता है 111. So 111 into 0.05 is going to give us 5.55 grams. अच्छा, अभी हम देखते हैं कि आगे क्या होता है और क्या नहीं. डू वी हैव एन ऑप्शन जिसमें 1 और 2 करेक्ट है? अच्छा, तो ये हमें पता चल गया कि ये भी टू एन एक्सटेंट ठीक है. 2 वाला ठीक है. 4.8 grams of carbon dioxide is obtained. तो अगर हमें ये देखना हो तो moles of carbon dioxide and then mass by mr, तो नहीं, इससे बनेगा 2.2 grams. So this is not correct and this is also, these two are not correct. तो इसका आंसर होगा 1 and 2, which is A. ठीक हो गया? this question is taken up. Now see how much working was involved, and this must be just 1 mark question. Okay, so if this much working is involved in 1 mark question, to first do the other ones and then get back to this question. Okay, okay, moving on to question number 30. Which gas sample contains the smallest number of molecules? 4 grams of helium, 16 grams of oxygen, 28 grams of carbon monoxide, 28 grams of nitrogen. Now, I told you the fact that molecules are directly proportional to moles. And as these samples have been provided to us in grams, so we can always take out the moles of these samples and then compare them to see which one has the smallest number of molecules and which one has the largest. Now let me clear the area and then I'll start with it. In order to find moles for helium, we will do moles is equal to mass over mr. So mass is 4 and the mr for helium is also 4. So this is going to give us 1. Okay. To find what is there in 16 grams, how many moles are there in 16 grams of oxygen, we will do moles is equal to mass 16 and oxygen में O2 होता है तो mr is 32, तो 16 by 32 is 0.5 moles. ठीक है. So 28 grams of carbon monoxide, moles is equal to mass is 28 grams and mr for carbon monoxide is 28. So this is going to give us 1 mole again. And then 28 grams of nitrogen. Moles is equal to 28 is the mass and 28 is the mr for N2. This is going to give us 1 mole as well. So all of these give the molecules to be 1 mole. So smallest number of the molecule would be present in 16 grams of oxygen, which gives 0.5. To get the smallest number of moles means smallest number of molecules. So B is the correct answer. Okay. Question number 31. The equation for the reaction between calcium carbonate and dilute nitric acid is shown. 25 grams of calcium carbonate is reacted with an excess of dilute nitric acid. Now they've told us that dilute nitric acid is in excess, so calcium carbonate is the limiting reactant. Which mass of calcium nitrate and which volume of carbon dioxide is produced as room temperature? TKG. So what we need to do is we need to find the moles for calcium carbonate because we have the mass for calcium carbonate. So moles of calcium carbonate would be 25 over mr is 100. So 0.25 moles. Okay, from these moles we can always find the moles for CO2 as they are in the similar ratio. So the moles for calcium carbonate would be similar for calcium for carbon dioxide. Okay, so once we have that, we also need the mass of calcium nitrate. This is also in a ratio of 1:1 with calcium carbonate. So iske moles भी would be equal to 0.25 moles. So let's just find the mass of calcium nitrate first. How are we going to do it? Moles is equal to mass by mr. The moles so we have 0.25 and mass we need to find, and mr for calcium nitrate is 164. So 164 into 0.25 gives us an answer of 41 grams. Okay. Once we've done that, let's move to CO2 and its volume. To find the volume, we need moles. It's equal to volume of CO2 by molar volume. And since the answer is in decimeter cube, so we just require 24 decimeter cube की value. So 24 into 0.25 is going to give us 6 decimeter cubes of CO2. Okay. So 41 grams and 6. C is going to be the correct option. Question number 32. Which gas sample contains the most molecules? Again, number of molecules and number of moles are directly proportional. So now we need to find the number of moles of each of the sample in order to see that which has the greatest number of molecules. Okay. So for the first one, 24 decimeter cubes of carbon dioxide, we have the volume. So we can find the moles with the formula moles is equal to volume by molar volume. Okay. Volume is 24 decimeter cubes and the molar volume ki value is also going to be 24 decimeter cubes since this is in decimeter cubes. This is the 1 mole of CO2 is there in 24 decimeter cubes of carbon dioxide. Okay, moving on to hydrogen. So hydrogen ka since the mass is given, so we are going to find the moles is equal to mass over mr. इस formula से तो mass is 4 grams and the mr of hydrogen is going to be 2. So 2 moles of hydrogen are there. Okay. Moving on to HCl. There are 36 decimeter cubes of HCl. So we are going to find the moles with the formula moles volume by molar volume. So volume is 36 and volume has to be 24. So 36 divided by 24 is 1.4 moles. Sorry, 1.5 moles. And for nitrogen, moles is equal to mass over mr. So mass is 14 and mr for N2 is going to be 28. So this is going to give us an answer of 0.5. 1 mole, 2 moles, 1.5 and 0.5. Hydrogen ka sample 4 grams of hydrogen contains the most number of molecules. Okay, so B is going to be our correct option. Okay, moving on to question number 33. A student mixed together 25 centimeter cubes of 1 mole per decimeter cubes of hydrochloric acid and 25 grams of calcium carbonate. What is the maximum volume of carbon dioxide gas that can be collected at room temperature and pressure? So again, we have the concentration of HCl and the mass of CaCO3, and we have to determine that which one of these two reactants is the limiting reactant and which one is in excess. So first thing is first we need to find the moles of CaCO3. How are we going to do that? We have 25 grams of CaCO3 and we have to divide it with our mr. So this is going to give us 0.25. Okay. Then we can find the moles of HCl by using the formula concentration is equal to moles by volume. So concentration over here is 1 mole per decimeter cubes. Moles we have to find and the volume is 25 centimeter cubes. So this is going to be 0.025 decimeter cubes. So the volume according to this concentration is 0.025. Okay. Now we need to see that which one of these is limiting and which one is in excess. So CaCO3 and HCl. 1 of CaCO3, 2 of HCl, and 0.25 of CaCO3 and X of HCl. So X is equal to 0.25 into 2. So this is going to give us an answer of 0.05. Okay, now if we look at this, in the reaction, according to the statement, only 0.025 mole of HCl was present. And according to the equation, 0.05 moles of HCl was required to completely utilize CaCO3, 25 grams of CaCO3. So over here, we've established that HCl was the limiting reactant because it was in lesser quantity than it was required. Okay? So what we are going to do now is that we are going to find the number of moles of CO2 using the number of moles of HCl. Okay? So HCl and CO2. HCl was 2 and CO2 over here is 1. And HCl had 0.025 and this has X. So 2X is equal to 0.025. So X is equal to 0.025 over X. So the number of moles of carbon dioxide are 0.0125. Okay. Once we have the moles, we can easily find the volume of carbon dioxide using the formula moles is equal to volume by molar volume. So moles are 0.0125, volume we have to find, and molar volume, since the answer is in decimeter cube, so we are going to be using 24 decimeter cube. Okay, so 24 into 0.0125 moles is going to give us the volume to be 0.3 decimeter cubes. Okay, so D is going to be our correct option. Moving on to question number 34. Which gas sample has the greatest mass? Okay, we have these samples with us, that are there in moles. So there is a simple formula that we have, which is moles is equal to mass by mR. So we are going to use that. For A, we have 5 moles. So the mass would be mass by Cl2. Cl is 35.5 into 2 is 71. 71 into 5 is going to give us 355 grams. Okay? So this has 5 moles of Cl2 has a mass of 355 grams. Over here we have O2. So mass, moles are 10. Mass we have to find, and this is going to be 30, 16, 32. Okay, the 32 into 10 is going to be 320. So 320 grams are there in 10 moles of O2. Moving on to that of nitrogen, though, moles are 15, mass we are looking for, and this is going to be 28. 28 into 15 is going to give us 420 grams of N2. And for this, we can do it over here. Moles are 20, mass H2 में 20 into 2 is 40 grams. So this is 40 grams. So now we had to find the sample with the greatest mass. This is 355, 320, so C, 420 grams. Because 15 moles of nitrogen has 420 grams of nitrogen in it. Okay, so C is going to be our correct option. Moving on to question number 35. Which sample of magnesium chloride contains the same number of moles as 69 grams of potassium sulfate? Acha, we need to clear the space. We've been given the weight of potassium sulfate, so we are going to find the moles of potassium sulfate from that. Moles of K2SO4. Mass is 69.6 grams and MR for K2SO4 is 174. So this is going to give us 0.39 moles, yeah, 0.4 moles, whatever you like. Acha. Once we have the moles of K2SO4, so we can simply find and see what happens. Okay. Acha, first sample is 19 grams of MgCl2. So what we are going to do is we are going to find its moles. The formula is going to be mass by mR. So mass is 19 grams and the mR for MgCl2 is 95. Okay. So this gives us the moles to be equal to 0.2. Okay. For the second option, when we have 28.5 grams, so this is the mass and this is the mR, so this is going to give us 0.3 moles. Okay. So when the mass is 38 grams, MR still is 95. So this is going to give you 0.4. And then there is the fourth one, which is 47.5 by 95. This is going to give us 0.5 moles. 0.5. So if you see that the moles for K2SO4 were 0.4, and C is the option that coincides with this because the answer required us to find the sample of magnesium chloride that contains the same number of moles as that of potassium sulfate. So C, 38 grams of MgCl contains the same number of moles as 69.6 grams of potassium has. ठीक हो गया जी? Moving on to question number 36. The equation for the reaction between potassium carbonate and nitric acid is shown. Which volume of carbon dioxide is produced from 69 grams of potassium carbonate? Okay. Carbon dioxide का हमें volume चाहिए, and we've been given the mass of K2CO3, which is potassium carbonate. So what are we going to do is that we are first going to find the moles of K2CO3. For that we need mass and we need MR. We have the mass to be 69 and MR for K2CO3 is, let's see, 138. So 69 divided by 138 gives us 0.5. Okay, now we have the moles and we see that K2CO3 and CO2 are in the same ratio, so the number of moles for K2CO3 will be equal to the number of moles of carbon dioxide. So we are going to use these moles to find the volume of carbon dioxide. And volume we can find by formula, moles is equal to volume by molar volume. So moles are 0.5, volume we are finding, and MV is, since the answer is in decimeter cubes, is 24. So 24 into 0.5 is going to give us 12 decimeter cubes of carbon dioxide was produced from 69 grams of potassium carbonate. So B is our correct option. Okay, moving on to question number 37. A solution of sodium carbonate Na2CO3 has a concentration of 0.03 moles per decimeter cubes. Which mass of sodium carbonate is dissolved in 1 decimeter cubes of this solution? Okay. We have a solution of Na2CO3 and we know its concentration. Okay. And now we need to find the mass of sodium carbonate that was dissolved in 1 decimeter cubes of this solution. So this is a simple question. First we need to find the concentration. Oh, sorry, moles. So we have the concentration, we have the volume, ठीक है? Concentration is 0.03 mole per decimeter cubes. Moles we are looking for, and this is 1 decimeter cubes. So concentration is also 0.03 mole per decimeter cubes. ठीक है? Sorry, moles are 0.03. ठीक है? Once we have the moles, we can find its mass by our simple formula. Moles is equal to mass over MR. So moles are 0.03, mass we are looking for, and MR for Na2CO3 is 106. So 106 multiplied by 0.03 gives us a mass of 3.18 grams. So B is going to be our correct option. Okay. Question number 38. The equation for the combustion of ethane is shown. Which volume of carbon dioxide at room temperature and pressure is formed from 0.5 moles of ethane burns? Okay. So we have been given the moles of ethane, we don't need to find them. And from that we can find the moles of carbon dioxide. So if you see that C2H6 and carbon dioxide. So 2 of ethane was there and 4 of carbon dioxide was there, 0.5 of ethane was there and X of this to 2x is equal to 0.5 into 4. So x is equal to 0.5 into 4 divided by 2. This gives you the moles of carbon dioxide to be 1 mole. Okay. Once we have the mole, so we can find the volume. Moles is equal to volume over molar volume. Moles are G 1 mole, volume we are looking for, and since the answer is in 20 decimeter cube, so we are going to use the value of molar volume in decimeter cube. So this gives us a volume of 24 decimeter cubes, which is B. Okay. Question number 39. A solution of ethanoic acid has a concentration of 2 mole per decimeter cubes. Which statement about this solution is correct? 20 grams of ethanoic acid is dissolved in 10 centimeter cubes of water. देख लेते हैं जी. We have the concentration. And then we need moles and volume. So 20 grams of ethanoic acid will have 20 by ethanoic acid ka MR is 60. This is going to be 0.33. So we have the moles divided by the volume, which is 10. So 10 to nahi hoga, to 0.010 decimeter cubes. So it gives us a concentration of 33.3. So अभी हमारी concentration नहीं है. We need a concentration of 2 moles per decimeter cubes. ठीक है. तो फिर हम second लेते हैं 30 grams. इसके moles निकालते हैं. तो 30 over 60 होगा. So this is going to give us 0.5 moles. और हम यहाँ कर लेते हैं concentration is equal to moles by volume. So concentration if we are looking for moles जो है हमारे 0.5 है and volume जो है हमारी वो 0.250 decimeter cubes है. So the concentration comes out to be 2 mole per decimeter cube. So we've reached our answer, which is B. We don't need to do these. ठीक है, अगर आपको चेक करने के लिए करना हो तो आप कर सकते हो, but हमारे पास ये आंसर आ गया, so we are not going to go forward because each and every question is so long and the video is becoming super lengthy. Question number 40. An experiment was done to determine the formula of hydrocarbon CXHY. 10 centimeter cubes of gaseous hydrocarbon was burned in an excess of oxygen to form 20 centimeter cubes of carbon dioxide and 30 centimeter cubes of water vapors. What is CXHY? Okay, this is a hydrocarbon. This let's just write our equation first. Okay, so this is a hydrocarbon CXHY, and it was burned in excess of oxygen. So this is going to produce CO2 and H2O. ठीक है, इसकी हमें नहीं, ये 10 grams था, 10 centimeters cubes. ठीक है जी. ऑक्सीजन जो था burned in an oxygen to form, ऑक्सीजन हमें नहीं पता. ठीक है, एंड CO2 जो हमारी है वो 20 centimeter cubes है और H2O जो हमारा है वो 30 centimeter cubes है. Let me just write this again clearly. ठीक है. Okay, now if we look at this equation and all the data that has been given, we see that, okay, once we've written that, we need to establish that 1 volume of CXHY gives you 2 volumes of carbon dioxide and 3 volumes of hydrogen. ठीक है, because this is a hydrocarbon, it only contains carbon and hydrogen. So what we've learned is that 1 CX over here produces how many carbons? 2 volumes of carbons. ठीक है. So over here C is equal to 2, sorry. And over here we've discovered that 1 of HY, since this is in a ratio of 1, so 1 HY gives you 3 volumes of H2. Okay. So now what we can deduce from here is that C in this formula is equal to 2. And H over here has to be 3 2s are 6. Okay. So the formula for CXHY is C2H6. Basically this is our option C थी. ठीक है. So इस तरह से इसको निकाल लेते हैं with the help of ratios. Question number 41. 4 grams of solid sodium hydroxide is added to water to make a solution with concentration of 0.200 mole per decimeter cube. What is the volume of water used? Okay. First we need to find the moles of NaOH. Okay, since we've been given its mass. So it's 4 by 40. This gives you 0.100. Okay. Once we have the moles of sodium hydroxide and we have the concentration as well, so volume of the solution can be found by concentration is equal to moles by volume. Okay, so moles are 0.100 and the volume, concentration was given now 0.200 and volume we are finding. So 0.100 divided by 0.200 is going to give us an answer of 0.500 decimeter cubes. But the answer over here is required to be in centimeter cubes. We are going to multiply it with 1000 and this is going to give us an answer of 500 centimeter cubes. So C is our correct option. Okay. Question number 42. The concentration of hydrochloric acid solution is 0.5 moles per decimeter cubes. How many moles of hydrochloric acid are present in 25 centimeter cubes of this solution? So we have the concentration and we have the volume and moles we have to find. We are going to use this formula. Mole per decimeter cube, moles, and the volume should also be in decimeter cubes, so we are going to divide 24/5 by 1000. So this is going to give us 0.025 decimeter cubes. So when we multiply 0.5 with 0.025 decimeter cubes, we get an answer of 0.0125 moles. Okay. So A is our correct option. Question number 43. Calcium carbide reacts with water to form ethine and calcium hydroxide. The equation for this reaction is shown. Which volume of ethine is reduced when 6 grams of water react completely with calcium carbide? Okay, we have to find the volume of ethine with the help of the mass given to us of water. Okay, as the mass of water is given to us, so we are going to find the number of moles of water. Okay, using our formula mass over mr. So the mass over here is 6 and the mr for water is 1618. Okay, so this is going to give us 0.33 moles. Okay. Now with the help of the moles of water, we can find the moles of ethine. How do we do that? We compare them and their ratios and their moles. So 2 of water and 1 of ethine was there and 0.33 of water and x. So 2x is equal to 0.33 and x is equal to 0.33 over 2. So this is going to give us 0.166 moles. Once we have the moles of ethyne, so it is very easy to find its volume. We can use the formula moles is equal to volume by molar volume. 1.66 is equal to volume that we need to find in molar volume, as the answer is in decimeter cube, so we are going to use its values of 24 decimeter cubes. 24 into 1.66 is going to give you 4 decimeter cubes. So the volume of ethyne produced when 6 grams of water reacts with calcium carbide is 4 decimeter cubes. Okay. अच्छा जी. Question number 44. Carbon monoxide burns in oxygen to produce carbon dioxide. Which mass of carbon dioxide is produced from 14 grams of carbon monoxide? Achha, we've been given the mass of carbon monoxide and we have to find the mass of carbon dioxide. So the first thing that we need to do is find the number of moles of carbon monoxide from the mass that's been given. So moles is equal to mass by mR. So mass is 14 grams and mR for carbon monoxide is 16 plus 12, 28. ठीक है जी, तो 0.5 moles are there for carbon monoxide in 14 grams of carbon monoxide. So once we have the moles of carbon monoxide, we can always find the moles of carbon dioxide, and since we can see that they are in the same ratio, so the moles of carbon dioxide would be the same for carbon monoxide. So now the mass can easily be found by same formula, moles is equal to mass over mR. So moles हमारे पास 0.5 है, mass we have to find, and mR for carbon dioxide is 44. So 44 into 0.5 is going to give you an answer of 22 grams. So mass of carbon dioxide produced from 14 grams of carbon monoxide is 22 grams. Yeah. Question number 45. The equation for the reaction between sodium carbonate and dilute hydrochloric acid is shown. What is the maximum volume of carbon dioxide produced when 26.5 grams of sodium carbonate reacts with dilute hydrochloric acid? Acha. Again, in this question, it's not mentioned that what is the limiting reactant and what is the reactant that is in excess, but we don't have a concentration or volume of HCl. So we are just going to use the grams of sodium carbonate to find the moles of sodium carbonate and then the moles of carbon dioxide and eventually its volume. So moles of Na2CO3 is equal to mass over mR. Mass of sodium carbonate is 26.5 and mR for sodium carbonate is 106. So this gives us a value of 0.25. Okay. Now, since we can see that the moles that sodium carbonate and carbon dioxide are in the same ratio, so the moles of carbon dioxide would be the same as the moles of sodium carbonate. ठीक है? Now we can find, by using these moles, we can find the volume of carbon dioxide produced. So the formula for that is moles is equal to volume of carbon dioxide by molar volume. And since the answer is in decimeter cube, so we are going to use a value of 24 decimeter cubes. So 24 decimeter cubes into 0.25 is going to give us a volume of 6 decimeter cubes. So A is our correct option. Question number 46. Gas hydrazine has a molecular formula N2H4. Hydrazine burns in air to form nitrogen gas and steam. Which statement are correct? 1 mole of hydrazine gives 72 decimeter cubes of gaseous product when it reacts with oxygen at room temperature and pressure. Acha, we can see that 1 mole of N2H4 produces this is 1 mole and produces 3 moles of gaseous product at room temperature and pressure. So 1 mole of gas occupies 24 decimeter cubes. 1 mole of gas occupies 24 decimeter cubes of space. So 3 into 24 is going to give us 72 decimeter cubes. So this is correct. Empirical formula for hydrazine is NH2. So we can just find it out right now. 2 and 2. So yes, this is correct. The empirical formula is NH2. The total number of atoms in 1 mole of hydrazine is 6 into Avogadro's constant. Okay, 1 mole of N2H4 contains 2 moles of nitrogen and 4 moles of hydrogen. Okay, so a total of 6 moles. Okay, since 1 mole contains 6.02 into 10 raised to the power 23 number of molecules. ठीक है, the total number of atoms is 6 times the Avogadro's constant, so 6 into 6.02 into 10 raised to the power 23. This is correct. Achha, the volume of 1 mole of hydrazine at room temperature and pressure is 6 into 24 decimeter cubes. Since mole is equal to volume by molar volume, and this is 1 mole of hydrazine. So volume over molar volume is 24 decimeter cubes. So this is going to give a volume of 24 decimeter cubes, and they've mentioned that 6 into 24 decimeter cubes. So this is not correct. It should be 24. So 1, 2, and 3 are correct by all the logics I've given, and D1, a fourth one is not correct. Yeah. So A is our answer for this. Question number 47. Copper 2 carbonate is broken down by heating to form copper 2 oxide and carbon dioxide gas. The equation for the reaction is shown. 31 grams of copper 2 carbonate are heated until all the contents in the test tube have turned green to black. The yield of copper oxide formed is this. What is the percentage yield? Okay. For percentage yield, we need the actual yield by theoretical yield into 100. So we have the actual yield, okay, and we need to find the theoretical yield. For that, we've been given the mass of copper carbonate. So first thing is first we need to convert it into moles. Okay. So mass is 31 grams and MR for CuCO3 is 124. Okay, so this gives us 0.25 moles of CuCO3. And since CuCO3 and CuO is they are in the same ratio, so the moles of copper oxide would be the same as that of copper carbonate. Okay, so we need to find the moles of with the help of the moles, we have to find the mass of CuO, ठीक है. So there are 0.25 moles. Mass we have to find, and Mr for CuO is 80. So 80 into 0.5 is going to give us a mass of 20 grams. So now we know the theoretical yield and we know the actual yield as well. So let's put it in the formula. 17.5 over 20 into 100 is going to give us a value of 87.5. Okay, so percent. So D is our correct option. Question number 48. Which sample contains the greatest number of molecules? For this question, we know that moles and molecules are proportional to each other. So first, we need to find the moles of all the masses that have been given to us. We have a simple formula that is moles is equal to mass by Mr, and we are going to use this in all the samples. So 4 is the mass, and for hydrogen, Mr is 1, so 4 moles are there in 4 grams of hydrogen. Acha, for water, the mass is 18 grams, and 16, 17, 18 is the Mr for water. So this gives us 1 mole. For 24 decimeter cubes of oxygen, now over here we have to use the formula moles is equal to volume by molar volume. So 24 decimeter cubes by 24 decimeter cubes is equal to 1 mole. And we are going to use this formula again. 66 grams by 44 is 1.5 moles. So the greatest number of molecules will be in 4 grams of hydrogen because it makes 4 moles. ठीक हो गया? Question number 49. Sodium carbonate solution reacts with dilute hydrochloric acid. The equation for the reaction is shown. Excess of sodium carbonate is added to 10 centimeter cubes of this much hydrochloric acid. Which volume of carbon dioxide gas is produced? Oh, okay. Now over here they've given us the concentration and volume of HCl. They've not given us the mass of sodium carbonate, and they've mentioned that sodium carbonate is in excess. So we don't need the mass of Na2CO3 because we in any case are going to use the moles of hydrochloric acid. Okay, since they've told us that this is the limiting reactant. So first thing is first we need to find the moles of HCl. We have the concentration. And then we have the volume. So moles over volume is the formula. So concentration is 0.10 mole per decimeter cube. Moles we have to see. And since this is in centimeter cubes, we need to convert it into decimeter cubes by dividing it with 1000. So this is going to become 0.010 decimeter cubes. So multiplying 0.10 mole per decimeter cube with 0.10 decimeter cubes, we will have the moles of hydrochloric acid to be 0.001. ठीक हो गया? We have these moles with us. Acha, now we are going to find the moles of carbon dioxide. Since we over here have HCl in a ratio and carbon dioxide in a ratio of 2:1, then we have the moles and then X. So 2X is equal to 0.001. And this divided by 2 is going to give us moles as 0.00005 moles. We have the moles of carbon dioxide. So now we can easily find its volume by using the formula moles is equal to volume of CO2 by molar volume. So we have our moles to be 0.0005 another 0 over here. And volume, and since the answer is in centimeter cubes, so we can use 24,000 centimeter cubes over here. So this multiplied by this gives an answer of 12 centimeter cubes. So A is our correct option. Moving on to question number 50. Sodium hydrogen carbonate undergoes thermal decomposition as shown. What is the maximum mass of sodium carbonate that can be made from 0.100 moles of sodium hydrogen carbonate? Okay, we've been given moles. Okay, and we have to find the mass for sodium carbonate. So how are we going to do that? We have the moles of sodium hydrogen carbonate, and we've got to find the moles of sodium carbonate. We know that they are in a ratio of 2:1. So over here we have 0.100 moles and x. 2x is equal to 0.100 and x is equal to 0.100 by 2. This gives us the number of moles of Na2CO3 to be equal to 0.05 moles. Okay, now we can find the mass of Na2CO3. For that we use our same formula, moles is equal to mass over mr. So moles are 0.05, mass we need to find, and mr for Na2CO3 is 106. So 106 multiplied by 0.5 gives us a mass of 5.3 grams. So B is our correct option. Yeah. Question number 51. The equation shows the complete combustion of propane. Which statement is correct? Okay, now we'll have to see everything about these statements and we'll have to solve them. And this is a very important question. It tells you a few very important tips and very important things and concepts that you need to remember for the questions that come in your CIA paper. Okay? Achha, while we are looking at the equation, and we know that nothing of sorts is given to us, like we haven't been given any ratios, we haven't been given any masses, we haven't been given any concentration or volumes. Okay, so we just have to look at the statement and look at if that statement makes any sense to us or not. Achha. First of all, if you see that the reactants and products are in a certain ratio. This is 1 mole of propane, and it reacts with 5 of oxygen, producing 3 of carbon dioxide and 4 of water. Okay, so these are the ratio between the reactants and products. Okay, so the first statement refers to the fact kg 10 centimeter cubes of propane cannot burn if less than 50 centimeter cubes of oxygen is present. Okay, if you look at the statement and we look at the, what do you say, the ratios, so we see that here 10 centimeter cubes of propane is there, and there is less than 50 centimeter cubes of oxygen present, and they have to be in the ratio of 1:5. So basically the oxygen at the moment is less than what makes a ratio of 1 and 5. Okay, so acha, should I go forward and then come back? अच्छा चलो, let's explain it. अच्छा, वो कहते हैं 10 centimeter cubes of propane cannot burn if less than this is present. No, it is going to burn. Propane is going to burn with whatever oxygen is present, but obviously that reaction is not going to give you a full combustion reaction. ठीक है? Because there is not sufficient oxygen present for propane to have a complete combustion reaction. ठीक है, it won't happen, but it this statement matlab takes it to another level and says that it is not going to burn and the reaction is not going to start. So the reaction is going to happen. They're not saying that if 50 centimeter cubes is not present, so then it cannot have a full combustion reaction. They are saying that 50 centimeter cubes is present, less than 50 centimeter cubes is present, and then the propane is not going to react with oxygen. No, this is not going to happen. Propane is going to react with oxygen, but full combustion नहीं होगी. इस वजह से this statement is not correct. वरना it makes sense. अच्छा, B में it states that 10 centimeters of propane would produce 40 centimeter cubes of liquid. Okay. Now you can see in the equation that one ratio, 4 is the ratio between propane and water, and 10 centimeter cubes of propane being there and 40 centimeter cubes of water being there. So this is going to give you a ratio of 1:4. So this is going to happen and this is going to be correct. But there is one thing that you need to understand. Okay? And that is okay, while the mole ratio of C3H8 and water is 1:4, correct? But this applies to moles. Like H2O produced is in liquid state. Okay? And Avogadro's law, which is volume ratio to mole ratio, only applies to gases at room temperature pressure. We cannot directly relate volume of gaseous C3H8 to the volume of liquid water using this mole ratio. Okay? So that is why this is not correct, because one of these is in gases and one of these is in liquid, and these can't be related with the Avogadro's law. Okay? So that is why it's not correct. You might be inclined to take this one as correct. हाँ हाँ ये 1:4 हो तो रहा है, तो this would be correct, but this is not correct because of this issue. ठीक है? अच्छा, the third one states that 100 centimeter cubes of oxygen would be sufficient to react completely with 20 centimeter cubes of propane. Okay. If we look at this, so 20 centimeters of cube of propane is there, and 100 centimeter cubes of oxygen is there, and they should be in a ratio of 1:5 in order to for the complete combustion to happen. So if we what do you say cancel, then to 10 twos are 20 and 10 tens are 100, and 1:5 ka ratio we can achieve with these specs. ठीक है? 100 centimeters of cube of oxygen would be sufficient to react completely with 20 centimeter cubes of propane, because this is the ratio that we require in order for this complete combustion to happen. So C is our correct option. ठीक है? And look at D, the reaction would result in an increase in the volume of gas. अच्छा, final volume is less than the reactants. ठीक है? It's always less than the reactant because some of it is going to escape, some of the product is going to get left behind. This is what we say is the theoretical reaction. ठीक है? In actuality, the final volume is less than the reactant. So simple बात है कि this is not correct. ठीक है? If you want me to explain it, so I can explain it in the way that one volume of C3H8 plus 5 volumes of O2 in the reactant side produce 3 volumes of CO2 gas, whereas this is liquid, so this is not going to go in ना. तो gas जो है वो देखो आप reduce हो गई है from 6 to 3 volumes. ठीक है? So that is why D is not correct. I hope you understood the concept. Question number 52. Sodium hydroxide reacts with sulfuric acid. The equation of the reaction is shown. Which volume of 0.4 moles per decimeter cube of sodium hydroxide reacts with 5 centimeter cubes of 0.1 mole per decimeter cube of sulfuric acid? Achha ji. Now, what is happening over here? That we need to find the volume of sodium hydroxide. ठीक है? That reacts with this concentration and volume of sulfuric acid. So first thing that we need to do is we need to find the moles of sulfuric acid. Okay. So how are we going to do that? We have a concentration and we have to find the moles and we have our volume. So concentration for sulfuric acid is 0.1 mole per decimeter cubes and volume is 50 centimeter cubes. So this would be 0.050 decimeter cubes. ठीक हो गया? So if we multiply this with 0.1, so moles would be equal to 0.005 moles. Okay, so now we know that we have this much moles of H2SO4. Now we can simply find the moles of NaOH. We can just write H2SO4, NaOH. So 1 of H2SO4 reacts with 2 of NaOH and 0.005 moles with X. 2 into 0.005. So this is going to give us the moles of 0.01 of NaOH. Now we have the moles of NaOH and we had the volume of NaOH as well. So now which volume is, we had the concentration of NaOH and now we have the moles, so we can find the volume. Concentration is equal to moles by volume. 0.4 moles per decimeter cubes and moles are 0.01 and volume is here. So we'll take the volume over there. So 0.01 divided by 0.04 is, this is going to give us an answer of 0.025 moles. But since the answer is in centimeter cube, so we need to multiply it with 1000. So after multiplication, this is going to give us 25 centimeter cubes. ठीक है? This was decimeter cubes and we have converted into centimeter cubes. So B is going to be the correct answer. Okay. Moving on to question number 53. Let me clear the space. Question number 53. The equation for the reaction between calcium carbonate and hydrochloric acid is shown. How many moles of calcium carbonate will give 24 centimeter cubes of carbon dioxide when reacted with an excess of the acid? So now they've told us that acid is an excess, so we've got to use अच्छा हमें तो moles of calcium carbonate ही निकालने हैं. So what we need to do is that first of all we've been given the volume for carbon dioxide. So we need to convert it into moles. ठीक है? So how do we do that? Moles of CO2 would be equal to volume by molar volume. So volume is 24 centimeter cube. So this is going to be 0.024 decimeter cubes by 24 decimeter cubes. ठीक है, तो this is going to give us an answer of 0.001. Once we have the moles of carbon dioxide, we can simply find the moles of calcium carbonate. ठीक है? As we can see that they are in a ratio of 1:1. So the moles of carbon dioxide would be the same for the moles of calcium carbonate. So D is going to be our correct answer. We've just found that out. Okay, 54. 25 centimeter cubes of 0.1 mole per decimeter cube of hydrochloric acid exactly neutralizes 20 centimeter cubes of aqueous sodium hydroxide. The equation for the reaction is this. What is the concentration of sodium hydroxide solution? Achha ji. We have the concentration and volume of hydrochloric acid. ठीक है? And we need to find the concentration of NaOH. So first, what we need to do is we need to find the moles of HCl. How are we going to do that? Concentration is equal to moles by volume. So concentration is 0.1 mole per decimeter cubes and moles we have to find, and the volume is 25 centimeter cubes, so it is going to be 0.025 decimeter cubes. Okay, so multiplying 0.1 with 0.025 gives us the moles of HCl, which are 0.0025 moles. Okay. Once we have the moles of HCl, we can simply find the moles of NaOH, and over here we can see that the moles of HCl and moles of NaOH are going to be the same since they are in the ratio of 1:1. So we can simply find the concentration with the formula moles per volume. So concentration we are going to find, moles are 0.0025 and the volume is 25 centimeter cube. So 25 centimeter cube, 20 centimeter cube. So 0.02 decimeter cubes is going to be the volume over here, and the concentration is going to be 0.125 mole per decimeter cubes. So C is the correct answer over here. Okay, question number 55. An excess of zinc is added to 100 centimeter cubes of 1.0 mole per decimeter cubes of hydrochloric acid. The equation for the reaction is this. What is the maximum volume of hydrogen evolved at room temperature and pressure? Okay. Zinc is in excess, so we are going to use whatever we have of HCl. So we have its concentration, we have its volume, so let's find. We will use the formula concentration is equal to moles by volume. So concentration over here is 1 mole per decimeter cube. Moles we are looking for, and volume is 100 centimeter cube. So 0.1 decimeter cube. ठीक हो गया जी? So this is going to give us 0.1 moles of HCl. So once we have the moles of HCl, we need to find the moles of hydrogen. HCl and hydrogen are not in the ratio of 1:1, so 2:1 and 0.1 into x. So 2x is equal to 0.1 and x is equal to 0.1 over 2. So this is going to give us the moles of hydrogen as 0.05 moles. Once we have the moles of hydrogen, there is no issue in finding the volume. So we will use a formula. We don't have the concentration now over here, so we will not use this formula. We will use the formula moles is equal to volume by molar volume. 0.05 is equal to volume by molar volume is going to be 24 decimeter cubes in this case. The 24 into 0.05 is going to give us a volume of 1.2 decimeter cubes of hydrogen. So A is going to be the correct answer. Question number, okay, I have left this question. Question number 56. Aluminium oxide has the formula Al2O3. Which statement about aluminium oxide is correct? 2 grams of aluminium atoms are combined with 3 grams of oxygen atoms. No, this is not correct, obviously. These are 2 molecules of aluminium and 3 of 2 grams of aluminium. No, this is also not correct. Aluminium oxide has a relative molecular mass of 102. Let's find out the MR of Al2O3. It's for aluminium it's 27 and it's going to be multiplied by 2, and for oxygen it's 16 and it's going to be multiplied by 3. So this gives us a value of 102. So yes, this is correct. Aluminium oxide has a relative molecular mass of this. Question number 57. The equation shows the reaction between magnesium and sulfuric acid. In this reaction, what mass of magnesium sulfate will be formed when 6 grams of magnesium reacts with excess of sulfuric acid? So we've been told that magnesium is the limiting reactant and H2SO4 is in excess. So what we need to do is we have the mass of magnesium. So we are going to find the moles of magnesium with this. 6 grams, and MR for magnesium is 24. So 6 over 24 is going to give us 0.25 moles. Once we have moles of magnesium, we can simply find the moles of magnesium sulfate. The moles for magnesium and magnesium sulfate would be the same because they are in the 1:1 thing. So simply use the formula moles is equal to mass by MR. मोल्स हमारे पास है 0.25, mass we have to find, and MR for MgSO4 is 120. 120 into 0.25 is going to give us an answer of 30 grams. So 30 grams of magnesium sulfate will be formed when 6 grams of magnesium reacts with excess of sulfuric acid. So C is the correct answer. Moving on. Okay, so we are finished with this topic of the mole concept, and I hope you understood this concept after we've done all these 57 questions. And there are so many concepts that have been repeated again and again, and there are so many formulas that have been repeated again and again. So I hope now you've learned those formulas by heart, and you know that which ones to pull out from the bag and where to apply those formulas. And I've told you about the linkage between molecules and moles, and I've told you about the linkage between the moles volume of the gas with the volume of the liquid and all. So I hope you understood this concept, and I hope that now it doesn't seem that difficult to you. So inshallah, see you in the next video. Take care of yourselves up till then. Allah Hafiz. Yeah, if you found anything helpful in this video, if this video has made you understand the concept in a better way, kindly remember me in your prayers and like and subscribe the channel.